In 1965, an engineer at NASA noticed an impending quirk of orbital mechanics. During the late 1970s, Jupiter, Saturn, Uranus, and Neptune were scheduled to drift into a rare geometric alignment, a specific, curving formation that only occurs once every 175 years. This alignment offered a massive physical advantage. By using a maneuver called gravity assist, a spacecraft could use the sheer mass of one gas giant to slingshot itself toward the next. This would aggressively multiply the spacecraft's speed, allowing it to traverse the outer solar system using a fraction of the normal fuel and time. To hit this exact window, NASA launched the Voyager 1 and 2 probes in the late summer of 1977. The immense speeds generated by these planetary slingshots guaranteed a massive secondary consequence. The probes would achieve escape velocity and leave our solar system entirely. Because these spacecraft were mathematically destined to drift through the Milky Way forever, engineers had to build a permanent ambassador capable of representing humanity long after the mission's scientific goals were met. On one hand, the Voyagers were designed as objective observers. They were outfitted with 10 highly sensitive scientific instruments, including magnetometers, spectrometers, and imaging systems, all built to act as humanity's eyes and ears in the void. On the other hand, they carried a 12-inch, gold-plated copper phonograph record. It was a literal message in a bottle, bolted to the exterior of the craft, intended for any extraterrestrial intelligence that might eventually find it. This creates a fascinating tension. A machine built strictly to gather cold, hard data about the physical universe was simultaneously tasked with explaining the human soul to the stars. As the probes whipped past the gas giants, they delivered staggering discoveries. They mapped the hidden rings around Jupiter, captured active volcanic eruptions on the surface of its moon Io, and gathered the first clear evidence of liquid on Saturn's moon Titan. The emotional peak of this observational mission arrived on Valentine's Day in 1990. At 6 billion kilometers away, Voyager 1 turned its camera backward one last time to capture a family portrait of our solar system, rendering Earth as a tiny, pale blue dot suspended in a sunbeam. Immediately after transmitting that final photo, engineers at NASA sent a command to permanently power down the cameras. They needed to save the spacecraft's dwindling radioactive power supply and memory for the journey ahead. With the cameras dead, Voyager 1 was now flying completely blind as it plunged into the uncharted, lightless edges of our solar system. This presented a unique logistical problem, tracking a blind spacecraft leaving the solar system. The answer lies in the heliosphere, a massive bubble of charged particles constantly emitted by our sun. The outer boundary of this bubble, where the solar wind abruptly stops, is called the heliopause. This chart shows the reading from Voyager 1's plasma wave instruments in the fall of 2012. Researchers noticed a sudden, massive spike in the surrounding electron density. Inside the heliopause, the solar wind had tapered off to almost nothing. But outside that boundary, the interstellar wind was dense and highly active. That specific surge in electron data proved Voyager 1 had pierced the heliopause, officially becoming the first man-made object to cross into the interstellar void. Now drifting in the silent dark, the probe's primary purpose shifted towards its secondary mission, the message to potential alien life. Building this message in the 1970s meant working against severe hardware limitations. Voyager's onboard computers possessed a total of 69 kilobytes of memory. That is a microscopic fraction of a single megabyte, making it impossible to store standard digital image files. To bypass this constraint, engineers developed an ingenious workaround. They projected 115 different photographs onto a screen, recorded those projections with a television camera, and converted the resulting video signals into audio waveforms. Those distinct sounds were then etched directly into the grooves of the analog phonograph record. These hidden audio photos documented the fundamental chemical blocks of life, basic human anatomy, and global architectural achievements. Visuals exactly like this one, showing people walking toward the Taj Mahal, were encoded strictly as sound. By using these analog recording methods, scientists managed to smuggle a detailed visual portrait of Earth past 1970s hardware limitations and out into the galaxy. There is a massive assumption built into this design. Any extraterrestrial species that intercepts the Voyager probe must possess the intelligence and the physical means to build a record player and then reverse engineer those audio waveforms back into static images. To help them along, NASA etched complex visual instructions directly onto the aluminum cover protecting the golden record. These diagrams are rooted so deeply in advanced physics and mathematics that most humans on Earth today lack the specialized knowledge to decode them. Beneath this cold mathematical exterior lies a curated emotional interior. The audio and images selected for the golden record deliberately omit all references to human war, conflict, or suffering. The golden record functions as a hopeful projection of our species, a collection of our ideal selves that excludes all mention of our own capacity for violence. Today, Voyager 1 is over 24 billion kilometers from home, hurtling outward at more than 60,000 kilometers per hour. But its active lifespan is drawing to a close. By 2025, the decaying radioactive plutonium that powers its remaining heaters and transmitters is expected to fully deplete. The probe will go entirely cold, dark, and silent. Once the power dies, Voyager drifts as an eternal monument to its creators, a silent golden disk carrying a whisper of humanity that may